Hello, Science 10, and welcome to Lesson 15 on chemical reactions. Now, chemical reactions, or types of chemical reactions, is not evidences of chemical reactions. Instead, we are going to take everything we've learned from how to make ionic compounds, how to make molecular compounds, solubility, balancing, skeleton equations, and add it all together with this last little bit on how to tell what type of reaction is occurring. So we're going to start in our notes with the very first one, which is called formation reactions. Formation reactions takes two parts and puts them together to make a compound. So it's two or more reactants, because there could be three reactants, but it's two or more reactants that combine together to make us a new product. So to keep it simple, this one would be sodium combining with chlorine to become sodium chloride. Right? That is a type of formation reaction. Now, the key part to this, guys, is this is the last part of our story because what is in front of you is a skeleton equation. If you had done your assignment up to this point, you would have your assignment, not only the chemical equation written out, it would be balanced. And now you get to tell me, hey, this is a formation reaction. So this is the last bit to that story. So formations take two or more reactants and make a new product. Decomposition is just the opposite. It's taking a compound and breaking it into its smaller pieces. All right. So you are now going to have a compound that has bonds breaking, and we break down into its simpler products. So water, for example, will have its bonds broken and become hydrogen gas and oxygen gas. That's decomposition, breaking down. Now, single replacement is something new that you haven't seen before or probably have talked about. But essentially, guys, it is just a simple swapping of whatever extra element you have on the reactant side. So what do I mean by that? An element will take the place of a cation or an anion in a compound. Huh? Essentially what it means is whatever you have extra of, swap it. So in this case, I have both. Sorry for that interruption. Okay, so what happens is you look for whatever there's extra of. In this case, there is A and B are both going to represent metals. This is a non-metal. So we just swap the two metals. So now A is with X and B is on its own. In this case, X and Y are representing non-metals. So I would swap these two so that Y is with A and X is on its own. So if we were to look at it in the context of actual chemical equations, the one below, look at the reactants. What do you have more of? Chlorine is a nonmetal and bromine is a nonmetal. So I have two nonmetals. On the other side, I'm just going to swap them. So now sodium was with chlorine and bromine's on its own. If we look down below at the next reaction, hydrochloric acid plus sodium, okay, looking at the reactants, I'm going to see I have sodium, which is a metal, and hydrogen, which can also act as a positive metal because it's a weird one, right? And we're just going to swap them when we go to the products. So that is a single replacement reaction, just trading whichever one you have extra of on the reactant side. The next type is called double replacement. This essentially just means take your two metals and switch them. All right. So we have different compounds exchanging ions. You guys actually have done this before when we talked about making ions and then making new products on the other side. So all you have to do is take them and exchange them. So hydrochloric acid and sodium hydroxide, where are my metals? My hydrogen and sodium. When I make new products on the other side, I'm just going to make sure that I switch their places. So now hydrogen is with the hydroxide and sodium is with the chloride. Now to remind you, you're probably thinking, huh, where did hydroxide go? Water can also be written as HOH. So here's my hydroxide and here's my hydrogen. I took hydrogen from here, put it with my hydroxide, took sodium here, and put it with my chloride. So I just swapped the two. All right. That's a double replacement reaction, just switching the two metals to be with two new nonmetals. The last one I'm going to talk about, and I will come back to that. Oh, it's skipping ahead on me. Sorry, guys, 1 second. The last one I want to talk about is hydrocarbons. Now, hydrocarbons, you may remember hearing the word combustion in grade 9, and we talked about how they will always produce water vapor and carbon dioxide. Now, hydrocarbons is literally an element that's made of just hydrogen and carbon, okay? But in the presence of oxygen and burning, hence the word combustion, it will always make water vapor and CO2 gas. This usually releases a ton of energy. So the example I have here is methane in the presence of oxygen will burn to create carbon dioxide and water. All right, so that's just an example of what is happening with a combustion reaction. So if we look at this diagram is just showing a little bit of a visual. I'm not a big fan of the double replacement visual, but that's okay. Essentially, it's showing formation, decomposition, single reaction, and single replacement and double replacement. Okay, we're not showing combustion because combustion will always make carbon dioxide and water. So here's a couple examples, and I want you to, as I'm talking through, take this, pause it, look at them, and think, do I know which ones these are? All right, 1, 2, there's 5 of them, I think, 3, 4, 5. So in order to understand what one you have, look at what am I starting with on this side? Do I have any compounds? Nope, I have no compounds. So if I have no compounds, it means I'm making something because they have to come together to do something. So I'm making a compound. This would be an example of a formation or making reaction. Okay, formation, to form. Okay. Oops, that says formation. So that's how I would approach a question, is start with what is on my reactant side. So what is on my reactant side? Oh, I only have a compound. There's nowhere to go with this. So I'm going to break this compound apart. Oh, if I break it, it's going to be decomposition. So hopefully you're starting to see how to approach these questions and how do you decide what kind of reaction they are. Okay, let's look at the next couple. So in the next one, again, I'm going to start with my reactants. What do I have? I have one element and a compound. Well, we got to make something new on the other side, so I guess I'm going to be matching this with this. But since this has got no matcher over here, this is a single replacement. Why? Because I'm not making two compounds. I'm making one compound and one element. What do I have on this side? Two compounds. Well, two compounds, they're going to switch around, so this is going to be double replacement. Now, the last thing you have to be careful of is these were pretty like just generic run through. Do I have this? Do I have that? Whenever you're looking at it, you have to look to see what does my compound have in it and is it in the presence of oxygen? So if you have a hydrocarbon, just C's and H's in the presence of oxygen, it's going to be combustion. Okay, so this is the fun part. I've now talked them through and I know you guys are starting to understand them, but now I'm going to tell you guys it in a little bit of a different way. This is Trogdor. Trogdor the Burninator. He's a dragon, in case you didn't notice. This is pretty much my drawing skills right here. But anyways, I did not make this. This is something that I know from when I was younger. I can't remember what the program was on the computer, but anyways, I'm going to explain to you using Trogdor the 5 reaction types. So in a decomposition reaction, I want you to think decomposing or breaking down. What that means is if I had a full Trogdor, this Trogdor right here, and I'm decomposing him or breaking him down, I'm going to break him in half. So down to simpler elements, his top half and his bottom half. That's essentially decomposition of a full compound. Let's pretend I have somebody, this is called strong bad, okay? Here is parts of this person. I want to make them whole again. So formation is about making them whole. So I'm going to take the bottom half of strong bad, the top half of strong bad, and here he is as a whole individual. Okay. So that is formation, to make or form. Now let's take these two guys and let's talk about it in the world of single replacement. If I want to replace one part, I'm going to need another part to replace it with. So here is the full version of Trogdor. He's my compound. And I just have a little piece of strong bad. What's going to happen in a single replacement is I'm going to swap to match these differently. So now strong bad's head is on Trogdor and Trogdor's head is on its own. That is single replacement, making a new compound by breaking the old compound. In a double replacement, I do the exact same thing, only this time, instead of one compound, new compound being made, I'm making 2 new compounds. So here I have a full Trogdor and a full strong bad. I'm going to break them both apart and form new compounds. Strong bad's head with Trogdor's tail and Trogdor's tail with strong bad's body. So, or sorry, strong Trogdor's head with strong bad's body. So here I went from 2 compounds to 2 new compounds, double replacement. Trogdor's a dragon. I said that. And what do dragons do? They breathe out fire. So he burninates the presence. Combustion is all about burning. It's all about burning in the presence of oxygen. You can't have fire without oxygen. Okay. So you are burninating the peasants essentially. Okay. So this is what's happening with this different reactions. So hopefully you understood and kind of got those in your notes and can start to see how we can, I guess, essentially come up with what type of reaction is which. We're now going to apply this understanding in an assessment that I will see and we will talk about at our next meeting. I hope you have a great night.